All right. Moving on, this is the Adept level video for parallel and perpendicular lines. So in this video, we're still going to talk about parallel lines only. So first off, we want to determine the equation of the line that is parallel to 2x minus y plus 4 equals 0 and passes through 1, negative 6. Okay, so just to recap what's going on. We are given a line. It's currently expressed in general form. Okay, we want the equation of a line that, not this one, but runs parallel to this one. And we're told that our line has to pass through this point. Okay, it doesn't tell us what form to express that equation, so we can use whichever one is easiest. Okay. Well, we know that when lines are parallel, the slopes are the same. So if we can determine the slope of this line, that must also be the same slope for our line. So what we're going to do is we're going to find the slope of this line, whatever it is, and then we're going to steal it. It's in general form, so it's not as obvious as it would be if it was in slope-intercept form. Okay, so let's just solve for y. Well, this is easy. Add y to both sides. Okay, so our slope is 2. The slope of their line is 2. Therefore, because they're parallel, our line also is a slope of 2. Okay, and we were told that it must pass through this point. Okay, well, we have the slope. We have a point. For that, we should use slope point form. So recall, that is just y minus y1 equals m times x minus x1. Okay, so we can just fill in all the stuff. So our y value is negative 6. Okay, the slope that we stole from over here is 2. We get to copy it. And this is x minus 1. So same slope, different point. And I'm just going to tidy this up. So this is y plus 6 equals 2 times x minus 1. Okay, so that is the equation of our line. It runs parallel to this one, but passes through this point. All right, well, let's graph this thing. So we know our line passes through 1, negative 6, so that is located right here. So it passes through that point, and we know our slope is 2, so it has to run up this way. Okay, so let's draw the line in here. Like that. Okay, and this was the point that we used. Okay, next it says express in slope-intercept form and verify the y-intercept is correct. Okay, well, we know, now that we've graphed our line, that our y-intercept is negative 8. Okay, so if we convert this to slope-intercept form, y equals mx plus b, hopefully we will get a minus 8 in there. So let's see that that actually happens. So we need to isolate y. No fractions in this one, so we're just going to multiply this one straight. This is y plus 6 equals 2x minus 2. Okay, and I just need to subtract 6 from both sides. Okay, and negative 2 subtract 6 is negative 8. And look at that. Okay, there's our line, slope of 2, and the y-intercept is negative 8. So this verifies that we did it correctly. Now, I didn't specify, but we could also graph the original line that they gave us just to show, in fact, that they are parallel. Okay, we certainly don't have to do this. This is extra, but I'm going to do it anyway. All right, so originally we took this equation and we expressed it in slope-intercept form so we could get the slope, because we had to steal it for our line because they're parallel. But we can actually plot this line. Their y-intercept is 4, so it touches here. And it has the same slope, so it runs up this way. So let's just draw it in here. Okay. we go. Should pop through. It's really, really slow today. There we go. Okay, so now we can see visually that the lines, yes, they do run parallel to each other. Okay, so next we want to determine the equation of the line that is parallel to 3x minus 2y plus 14 equals 0, but has a y-intercept of, an x-intercept of 5. So, might seem different than the previous example, but it's actually pretty much the same, because they actually did give us a complete point, because if the x-intercept is 5, that means the y value has to be 0. It can't be anything else. Okay, so, as before, since they're parallel, we need to determine the slope of their line so we can steal it and apply it to ours. So, it's in general form right now. Okay. So, just going to solve for y, and I think that's easiest if I add 2y to both sides and express it on the right, because that way it's positive. So now I don't have to divide by any negative numbers. Okay, so these cancel. So I just get y equals. Now, 3x over 2. Well, 3 over 2 is not reducible, so I can write that as 3x over 2 or 3 halves x. Now I have positive 14 over 2. That's positive 7. There we go. So that's their line. And the slope is 3 over 2. So the slope of our line must also be 3 over 2. So before we actually get to our line, why don't we plot this one? Let's plot their line. I'll do it in black. So their y-intercept is 7, so that's up here. Okay, and rise over run, so that's up 3, right 2, or I could go down 3, left 2, either way. So I'm just going to get that line in here. That would be like that. There we go. Okay, so let's get our line. So, because we have a slope to work with and a coordinate, we can use slope point form. So remember slope point form? You've seen it above. So we have y minus 0 equals, I'm going to use their slope, 3 halves, and this is x minus 5. Okay, now I'm actually going to plot this right now. Okay, the x-intercept is 5, so that's right here. Our slope is the same, so we have to go up 3, right 2, just like that. Let's get our line in place. And we draw. There we go. So yes, I can see that they're parallel. All right. Okay, so that's done. Though, if we wanted to maybe simplify it a bit, the 0 is not necessary. Okay, so there's a simplified slope point form. But now we want to express our equation in slope-intercept form and verify that the y-intercept is correct. Now my y-intercept, I didn't draw the line long enough, but looks like it would cross somewhere around here. You know what? I'm going to extend my line because I can. Right. Right, so down. Something like that. Now it appears that the y-intercept is actually not at a particularly nice number. Okay, so let's see that that actually happens. Okay, so we want to take our equation and express it in slope-intercept form. Okay, so for that we need to isolate y, which, well, it actually already is, but we also don't want it looking like this. We don't want brackets. So we need to expand this out using distributive law. So 3 halves times x is just 3 halves x. That's all right. Now we're going to multiply 3/2 times -5. Well, a positive times a negative we know is negative. Okay, so we've taken care of our sign. So now we can ignore 3/2 times 5/1. Okay, that is going to give us 15/2. Okay, so again, that's y. Okay, so our y-intercept is -15/2. I'm going to write that as a mixed number so that we can better compare it to where it crosses on the graph. Now 15/2, that's just 7.5. Okay, so if we look here, look where it crosses the y-axis. Well, this is -5, this is -6, -7, and it looks like it crosses halfway between -7 and -8. So we verified that here. Okay, so just one note. If this was a test question and you had something like this, as long as it's reduced, you're fine. Okay, you don't have to convert this improper fraction to a mixed value. But of course, if it's a multiple choice test, you might have to do some converting so that you can actually get the desired result.